Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by AWS and Lumigo. My name is Cody, and I'd love to welcome you back to Techstrong Learning for another exciting presentation. Before we get things rolling, I do have a couple of housekeeping notes I'd like to go over. To start things off, today's session is being recorded. So if you miss any of our discussion, perhaps you'd like to rewatch or share with your team later, you will be receiving an email with a link to access this recording on demand. If you'd like to engage with us, and I'm sure you'd like to, there are a couple of ways for you to engage with us. The first of which is the chat tab on the right side of your screen. So I'd like you to start testing out that function for us by letting us know from where in the world you are joining us. If you have any specific questions, we want you to send those into the Q&A tab directly on the right side of the chat. Sending in your questions to that Q&A helps us keep track, and we will be kind of pausing between sections here today to look at those questions. So if you have a relevant question, please do send it in. We'll try to tackle it as soon as we can. Additionally, before we close things out today, we are going to give away 4 $25 Amazon gift cards. So be sure to stick around to make sure you're one of our lucky winners. So our topic today is troubleshooting serverless in production. And I'm joined by Alex Deboutre, VP of Engineering at Theodo US, and Ron Netzer, Director of Product at Lumigo. So Alex, Ron, thank you both so much for joining me today. Ron, do you want to get us started and start laying down the groundworks?
Sure. So thank you, Cody, for the introduction. Alex, always a pleasure to have you and co-host the webinar. Today we're going to talk about Troubleshooting Serverless in production. Alex and myself prepare a few topics that we would like to share and walk you through. We're going to talk about how to troubleshoot serverless application with distributed tracing. We're going to talk about how to identify specific failed invocation with the feature we call execution tags. We're going to talk about customized warnings, basically when you want to be alerted on issues that not necessarily interfere with the service, so warnings. And also, we're going to talk about troubleshoot timed out invocations. And with that, I want to hand over to Alex that's going to walk us through the application architecture that we're going to do the webinar today. Alex.
Yeah, thanks, Ron. So hey, hello everyone. I'm Alex. So at Theodo, we're a serverless software consultancy. So we build a lot of serverless applications for our clients. And our example today is a reduced example from a real app, that's in production at a real client. So this client has a lot of salespeople. And so we built a custom platform to enable them to do their jobs better and faster. So the simplified version today has mostly 2 functions. The first one is to create a deal. So there's the post endpoint through an API gateway that triggers a create deal lambda. Then we call a third-party service that generates cool names for our deals because, we're salespeople. So all deals need to have very cool names. We store that in DynamoDB. We also send an event to EventBridge that's going to trigger downstream integrations to Salesforce and other services. And then we also have another point to API ID. So simple API gateway endpoint triggers a get deal lambda that gets the deal from DynamoDB and returns it to the user. And yeah, that's about it for the application.
Amazing. Thank you, Alex, for the overview. And let's start. The first thing on the agenda today is troubleshoot serverless application with distributed tracing. For that, Alex was willing to prepare some kind of use case that he's going to present us. And basically, we're going to start with how troubleshooting serverless application without distributed tracing looks like before we even talk about distributed tracing. So Alex, handing over to you.
And so one thing I want to make clear before we go further, right? We're talking about troubleshooting in production, right? So our app has already been through dev, through staging. So most of the most of the bugs have already been worked out. And so now we're like, okay, we're in production. How do we catch bugs in the wild, when they're not that easy to catch? And so I'm going to share, right? So we deployed our app. I actually used SST for this app. So we have our code and everything. And I'm using this app, and I'm trying to create deals. And so I have this, just creating deals. And you see I have very cool names. But then once in a while, I get a lot of very cool names right now. Awesome dog, awesome fish. Right. Once in a while, I get a name that's not that cool. Right. There's no animal involved, no super cool adjective. And so I'm wondering, like, oh, crap, this is happening in prod. What's up with it? So on Lumigo, I'm going to try to find like the trace for the invocation that I just did. So I'm going to go to my function that creates deals, and I'm going to go a little bit in the past to when I tried this call. And I can see here, right, it looks like I had an error. That looks about right. I have the logs, but that's pretty much it, right? I have logs. I have an issue, but I don't have anything else. And so if I want to debug further, I'm going to have to add logs, right? Well, I think we've all been there. I'm going to have to change my code. I'm going to have to deploy in production. I'm going to have to reproduce the error. And so that's not really fun. So Ron, how can we make this better?
So Alex, this is amazing questions that we hear a lot of our users asking us again and again. And one of the things that you can do is basically use distributed tracing. So for the ones here in the audience that are less familiar with distributed tracing, what it is before even showing it. So basically, it means it's a way to collect information about how the components of your application work with one another to serve end-user requests. Basically, you want to understand the request as it goes through your application and the payload that each request, and the payload basically of each request. Now, distributed tracing data is collected by something called tracers, which are add-on to your applications. Now, there are a few ways to deploy tracers. One of them is you can use the serverless framework, you can use NPM, Lambda layer, CDK, but one of the things that Lumigo does well or very well is basically you can deploy the tracer via the Lumigo platform, via the UI, with only one click, and Lumigo will inject the tracer to your Lambda function, which means you as developers won't need to do any code changes or deal with any other framework. So, Alex, I think that for the demonstration and for this webinar, what I suggest is that you will open your platform and I will show you how easy it is to deploy the Lumigo tracer via the UI.
Perfect. So I'm here. Where do I go? Oh, sorry. Do you see my screen now, Ron? Okay, sorry. We might have lost Ron for a second. So I'll go in functions. And so here I see all of my functions. I added a tag to see only my production functions. And here there's a little toggle, right, so that I can automatically trace my functions. And so I'll just activate it everywhere. And after a little bit, because there's some deployment happening on the AWS account side, they will all be traced. And this means that, right, nice, they're getting all traced. And so this means that the next time I invoke my function here, call it once. Perfect, I had the bug already, but I could call it a few more times. Then if I go back here, I go back to my post invocations. Here you see I have more icons, and this is because if I open one of them, I see a distributed trace, which is much better than what I had before, right? I still have what I had before, my final issue, and then the logs at the bottom, but I have a lot more information, right? I have return values for my function. I have the original event that triggered it with everything in it, the headers, the context. I have the environment variables because that's often a problem in our apps, as I've noticed along the years. And more importantly, I see every interaction that this Lambda had with other services, right? I see how it was triggered. So here it was an API gateway route with this URL. And then I see that it triggered an event bridge. I see that it called a third-party service. I see that it had an interaction with DynamoDB, and I see actually exactly what was created. And so this way I figure out, okay, this function had an issue because my getCoolName third-party service crashed and had a problem, right? And so this is really, really powerful. As a dev, this has been, just honestly life-changing. Because this works, like here I deployed myself the getCoolName service, but this works with any third-party HTTP request that you make. And so, when you're using external APIs, you can understand like, okay, what exactly went wrong? What did I send? What did I get as a response? A lot of third-party APIs these days give you like request IDs to be able to follow up on bugs and issues that you have. So you can see the individual request IDs of every call that you make and all that without adding logs, which is a pretty big win in my book.
Amazing. Alex, I think that you presented the feature and the use case better than I could. One thing that I want to share is that one thing that we hear often here at Lumigo, and I know that Silvio will hear this as well from their customers, is that how convenient this view is. Basically, you get all the data, all the information you need to troubleshoot and basically identify the root cause very easily, visually, and also everything in context. So you're not looking just on a specific invocation, but you understand the big picture from the API all the way to the last service that serve this request. And without doing anything, just hit the tracing toggle and you get it for free. You didn't, as a developer, as Alex mentioned, you don't need to go ahead and start writing your own logs. Another thing, Alex, there is, if you can click on the timeline view, the timeline tab. So yes, there is the graph, but another view that you should be aware of sometimes in some cases, especially when you are trying to troubleshoot duration or latency issues, then the timeline view is the go-to view, which basically allow you to see the latency of each service. And by that, what we're gonna do now is we're gonna talk about, so we basically talked about troubleshoot serverless application with distributed tracing, and it's time for questions. So one question that has been asked is if this work with PHP. So the answer is at the moment not. PHP, it's not a supported runtime. The supported runtimes are Python, Node, Java, .NET, and Go. You can find all the supported runtimes in the Lumigo documentations. And for each runtime, you can also find a specific instruction how to deploy the trace. Cody, are there other questions?
Yeah, it looks like we received one more question. What are some best practices for monitoring observability in serverless environments to quickly identify and resolve issues?
So basically, this is a great question. There are all kinds of ways. Alex and I are gonna present some of them during this session. But in general, I like to think about, and then Alex, definitely you can also share. But I like to think about it as depend on your job. Some developers like to be reactive, meaning to react to something when something happens, which in this case, what we usually suggest is to make sure that you have the right alerts in place. So when every time something is happened, make sure that you get notified, that you're being notified in the right channel, so you can go ahead and troubleshoot and react. Then another approach is to be proactive, and we have a lot of users doing that as well. Basically, they start their day in the Lumigo platform, and we're going to show it a bit later. We have a page called Issues page, where basically what you can do is you can review all the latest issues. And this is a great starting point to basically monitor and understand what happened in the, for example, during the night, and start triaging your application from there. Those are the two approaches, and again, we're going to present all kind of other features that basically allow you to monitor more tightly your application. Alex, do you want to add on top of it?
Not really. Be proactive. The worst thing that can happen is that you have an error and then you don't have enough information to troubleshoot it, and so it forces you to change something and then reproduce the error, which can be hard, especially in a prod context. So yeah, what we're going to show in a sec is what we do on all projects to make sure that we're not missing any kind of information and we can always identify errors.
Amazing, thank you, Alex. And with that, great questions. Thank you for that. And with that, let's continue to the next topic. Identify specific invocations. Alex, please share with us your use case.
Yes, so this is actually a real message from a real client, right, that has a sales app that we built for them. And, they're saying, hey, something happened to a user, right? So they were like, oh, there's this specific user and this specific deal, but we don't really know when it happened. And it's unclear really what the root cause of the problem is, right? So it's a classic user-driven bug report, and it's hard, this kind of thing, because the first thing that you have to do is to find in your monitoring or observability system, the actual time when it happened, to find a log or to find more info about the bug. And so, Ron, how can we with Lumigo pinpoint exactly when and where this happened?
So this is a great question, and I really like this use case because this is something that we repeat itself. And let's be honest, not all invocations are equal. Some of them are more important than others. And basically, what you want as a developer to be able to identify the specific invocation, the one that you really care about. So for that, Alex, we have a feature that we call execution tags. What are execution tags? Then basically, it's a way to enrich your traces with metadata, using tags. So all you need to do, very easily, you just, there are all different ways to add tags, but if you would take the Node.js, for example, all you need to do is just to install the Lumigo tracer and then add the execution tag to your handler code as such. Very easily deploy your function, and then when an invocation, then basically what you can see is on the transaction graph, the page that we just saw before, you will also be able to see the specific key and value. Okay, and not just that, you will also be able to look for specific invocations based on either the key or the value. And Alex, I'm gonna show you how to do it in a sec.
Okay.
So handing over to you.
Okay, so showing this. Whoops. Yeah. So I added these 2 lines to my code, right? So this is in the get call. So I added an execution tag to tag my invocation with a deal ID, and another one to tag it with the user ID that I get, from like an authentication header or something like that. And then, yeah. So then on Lumigo, where do I go?
So once you did this, all you need to do is to go ahead and, for example, go to Explore, to the Explore page, and very easily scroll down. You see the distribution panel on the left, then scroll down, and then you will find a filter called execution tags. Go ahead and expand this one. Now, the first thing that you need to do is you need to filter by the key. Okay?
Gotcha. So here I know that my user was in S, so I'll filter first by user, and then again by in S. Perfect.
Exactly. Now what you see here. Sorry, Alex. Go ahead.
I was like, now I've got my transactions, right? So most of that's it. Bug solved. But yeah, so then like this is when I can start like the actual work, right? I've pinpointed the thing, so now it's like classic bug solving. So I open this, and then like before I see the full transaction, and here, this helps me dig deeper into the error. I'm like, oh, you can't see this deal. And then if I go into my code, that's here, I can find that, yeah, if the first letter of the deal is the first letter of the username, I get an error, classic bug. And so yeah, this saves me a lot of time in terms of identifying what was going wrong or where it was going wrong, so that I could focus on like actually solving the bug.
Yes, so it looks like you got it. And basically, one last thing is also on the side panel to the right, you can see the execution tags at the top.
True.
So you know that this invocation is basically tagged with specific user
deal ID. And actually, you're wrong, because like not all of my customers are equal. So maybe for example, Ines is a VIP. And I have like a very stringent SLA where I have to answer any bug very, very quickly. So how could Lumigo help me with that?
Yeah, so again, it's a great question. Again, something that we hear a lot and we hear often. So specifically for this use case, we developed and we recently launched a feature which we called execution tags based alert.
Mm-hmm.
So what you can do is you can trigger alerts only for failed invocations that are tagged with specific tags. It can be either key value or a key value pair. To do so, very simple, click the alerts button on the navigation panel, then create new alert. For the name, just enter, for example, the name of the customer. So every time that you will get alert, you will know, okay, this is the alert for this customer. Select the lambda here. Expand the condition. Now, select events. You can, basically, there are all kinds of, let's say, errors that you can. So select, go with any error. So anything that happened with this. You can also mute the 400 errors. Usually you don't want to get a notification from that, so just check exactly. And now what you see here, you have all kinds of ways to apply resources or apply functions to this alert. So what you need to do in order to get alert just for this specific customer is pick the selected execution tags. And here what you will find is you should find a list of all the execution tags, but if you don't find, if you don't see your execution tags, in the list, then all you need to do is just enter it manually. And the next time that an invocation will fail, and this specific invocation will be tagged with this tag, then you will get an alert.
Okay, that's really cool. Thank you very much.
And with that, let's continue. So,
Do you want to take another round of questions, Ron?
Yeah, we're gonna take it, but yeah. So let's see, Cody, do we have other questions?
Yes. Are you able to create self-healing conditions?
Again, what?
Self-healing conditions. I believe this was in reference to our last round of questions.
Yeah. So I'll take this one. So usually, like when we work with serverless applications, the self-healing kind of comes from the managed services, right? So like Lambda will itself be resilient and will have retries built in, especially when you call them asynchronously. Most of the architecture is going to pretty naturally end up being async through events, through step functions, through SQS, like queues and so on. And then the rest is like, hey, what do you actually need in your application? Can you work without, can you have degraded modes when some third-party services are down or things like that? So I will say that as a dev, that's also in charge of deploying my own applications most of the time, it's really nice not to have to worry about this kind of this part of infrastructure too much. So yeah, so the next question is challenges when running serverless applications in production, but this is to me a big plus of using serverless in production, is that usually like the services that we use are pretty resilient by themselves, and we don't have to spend a lot of time or effort working on that additionally. Yeah, I hope that answers the question.
Yeah, it looks like we did have one more. It says, with all these tracers turned on in production, will it impact performance?
So this is a great question. The short answer would be yes, but the overhead latency that the tracer will add is neglected. Like it won't degrade the performance of your production environment. And I hope
simple as that. And maybe I'll tell a little more about challenges when running serverless applications in production. So because I was more specific before, but overall I find that running serverless applications in production is easier than running non-serverless applications. For different reasons, but for example, I find it easier to have the same infrastructure in a dev environment and staging environment and prod environment with serverless, because you're using managed services, so you're just using exactly the same thing. You use infrastructure as code so that you make sure that your stacks are exactly the same, which gets rid of a ton of bugs related to like changing underlying infrastructure when changing environments. I will say that when we started doing serverless a while ago at Theodo in 2017 or 2018, there were a lot fewer solutions like Lumigo on the market. And so troubleshooting was really, really hard, right? Because like when you have a classic server, at least you add a ton of logs and kind of everything is happening in the same place. Or, you have like a handful of microservices, but at least it's not that hard to see all of your logs in the same place and try to make sense of something. But then when you become serverless, all of a sudden to make sense of one like logical transaction that goes from, a request to a response, there is actually 10 different services involved. And if you have to check logs and troubleshoot 10 different services, it's really, really hard to make the correlation between them. And so this is why like we're such fans of Lumigo because it gives us that correlation and a like end-to-end transaction view to really understand what's going on and not have to, you know, find needles in a haystack in terms of logs and errors at the troubleshooting step. So yeah, so it was a bit long-winded, but that's my 2 cents on that.
Yeah, so on that, I want to also add another thing about the Lumigo. Alex, I'm very happy to hear what you say. Now, if you decide to troubleshoot or monitor your serverless application with Lumigo, then you need to know that unlike other vendors out there, you don't need to install any agent. It's basically very easy. All you need to do is to sign up and connect your AWS account with a simple CloudFormation template that create an Ironwall. With this Ironwall, basically Lumigo can fetch all your resources, all the functions, and very easily, in a matter of like 5 minutes, you can already see your functions in the platform. And with the distributed tracing via the UI, what Alex demonstrated before, you can very easily start tracing your function and get and start getting alerts immediately. So from sign up to actually seeing and start troubleshoot your production environment, it's a matter of 5 minutes, literally 5 minutes of marketing. It's like, this is the time it takes to the Ironwall to be created, and this is the time it takes to deploy the tracer automatically. And the second that the function will throw an exception, then you will be notified and you will be able to troubleshoot it via the platform. So far, we covered troubleshoot serverless application with distributed tracing. We talked about how we can use execution tags to enrich our traces so we can identify specific invocations. We also, on the same topic, we show how you can set up alerts. So you will be alerted on specific invocations. And the next topic that we're gonna talk about is customized warning. Why do you want them? Because sometimes you want to know when there is something that is happening with your application that doesn't necessarily interfere with the service. For example, it doesn't necessarily need to be a fatal error that caused the Lambda to crash, just a warning. Alex.
Yeah, so I think a good example in the stack that we have is that get cool name service, right? Like, it's not the end of the world if we don't get a cool name for a deal. You know, it's sad, but it's not the end of the world. So we can just, like, you know, catch that error and generate a not cool name locally, but then I still want to know, like, when my third-party service fails, right? Because maybe I have a contract, you know, and it has an SLA, so I want to make sure that, you know, it's not failing too badly, or just I want to have stats about it. So how could I do this with Lumigo?
Yeah, so for that, again, as always, we have a feature that can help you. And again, sharing my screen. And we call it customized warning or programmatic errors. Basically, it's a way to customize your own error messages. There are a few ways to do so, and all kind of errors. You can just configure a generic error, meaning every time the condition will be met, then what you will see is just a generic programmatic error on your in the platform. Or even further, if you want to get a specific, customized error message, then you can configure a custom error. So whatever you define in the code, this is what you will see in the platform. And of course, as we showed before with the execution tags, you can also apply alerts on programmatic errors. So you can be alerted also on warnings, not necessarily just on errors. So Alex, I noticed that your application is with nodes, and this is the how to implement programmatic errors. And now, if you're willing to share your screen and show us how you did it.
Perfect. So yeah. So right, I already had a try catch around my fetch to that third-party API to get cool names, and so I just added this line, right? That's the one that you showed. So I have the error message from the API, and I said, oh, type is a cool name error because it comes from that generate cool name service. And so now if I go in Lumigo, as I noticed, and I go to issues, right, where I see like everything that gets wrong with my app, and there's quite a few. If you guys have used like, any other tool like that before, you're familiar with this. So here I see my cool name error, and I like that it's orange and not red, right? Because it's not that bad. It's just a warning. And yeah, here I have a lot of really cool info about my error. I have the last transaction. If I want to explore in more details, what exactly happened and what was the impact of my error and so on. I can see stats. This is useful if I want to know if it's happening a lot or not. And yeah, just a ton of other info that's useful. This can be pretty useful, if sometimes one error will trigger another one, but it's hard to see. So this is to see, okay, is this error actually, no, sorry. This is more like, okay, this function, what are all of the errors that it gets and so on. So yeah, just a lot of really useful information that's going to help me troubleshoot or just follow what's going on with this issue.
Yeah. Alex, can you scroll down a bit back to the widgets that you just showed us?
Yep.
So this is basically a very interesting widget, the other issues with the resource. Basically, this feature is, let's say, help you to understand the collateral damage of an issue. Sometimes when you have an issue with one type of issue with the function, sometimes it means that there are other issues that maybe correlate or relate to this issue, and you're just not aware of them. And this is the feature that show you the collateral damage. And we here also, I think it was a month and a half ago, where a user did the same flow as you just showed us. And when he went to this, when he looked at this feature, basically he identified a most severe issue, which was the actual root cause to the issue that he was reviewing at the moment. So this is a nice feature that you should be aware of and try to utilize.
Nice, that's really cool.
Cool. And now this was quite straightforward. So, any questions so far? Any other questions?
Doesn't look like we have any just yet.
Okay. So the next thing that we're going to talk about is troubleshoot timeout invocations. Alex, why important? Why do I need to troubleshoot timeout?
Right, timeouts are never fun, right? So when we're serverless, right? So usually our apps have pretty similar behaviors in staging and prod, but that's not always the case. Sometimes we have a SQL database, and so requests will take more time because we have more data in our prod database. Or sometimes the behavior, like the performance of third-party services, will be different between staging environments and prod environments. And so timeouts happen, right, on Lambdas, and they can be pretty hard to detect, and especially to troubleshoot. So yeah, what do you guys have for that?
So there are all kinds of reasons that can cause a function to time out, from configuration to a function that just wait for an input-output process to complete, which is longer than expected, etc. Now, usually, troubleshooting timeout invocation is, as I see it, you need to adopt some kind of holistic approach. So the first thing that you want to do is you want to be aware. Anytime you want to be aware that timeouts happen. So the first thing that I will do is, and I'm going to share my screen, is I'm going to set up alert. Now, so how to set up alert for timeouts? Basically, we have two types of alerts that can be helpful for this case. The first one is very similar to what we did before. Just open the alerts page, then click on the create new alerts. And what you need to do is, again, select Lambda as a service. This time I just call this alert function timeouts. And in the condition, what I did is I select timeout. So basically what I'm saying is I want to be notified every time each of my functions is timed out. Another thing that you can do is you can select the invocation about to timeout as an event. Basically, this is a more proactive approach. This will trigger an alert every time the timeout configuration, the timeout or the duration of the invocation exceeded 95% of the timeout configuration. So basically, when you start to get this type of alerts, you know that maybe you should do something, either increase the timeout configuration or improve the performance of the function, so you won't experience the timeout later. Now, this is not the only thing that we care. Is now in this specific project, I'm monitoring both my development application and my project production application. But what I really care about is timeout invocation in production. So one way to make sure that I'm not getting too much alerts is I'm using a feature called resources with Amigo tags, meaning I want to get these alerts only for lambdas, lambda function that have a production tag or a production label. This way I can ensure that I'm reducing the alert noise and basically being alerted and get notification only for my production functions. Another thing, in this case, I also setting up this alert to send me a notification directly to my Slack channel and also to my email. And I can also set up PagerDuty, OpsGenie, or other various channels, and just make sure that every time one of my invocation, one of my production function is timeout, I'm being notified in all the relevant channels, and I can troubleshoot. Now, so we talked about awareness. The second thing that we need to do is basically we need to find out the root cause, what caused the function to time out. So all kind of ways to do it with Lumigo. What I like to do is I like to start with the functions page. Basically, this page here, I can see the list of all my functions. Now, in this webinar, we filter by the production because this is what we care. And the reason, a very interesting feature here, which is the average duration. Basically, what we can see here is the average duration of this function, and we can see that the average duration of this function is 5k millisecond, give or take, a bit more. The max configured timeout is 7 seconds, and the average to max utilization is 82%. Meaning I'm on the safe side, but I need to take a closer look. Sometimes this can act as a warning. And whenever the average to max utilization exceed 95%, then Lumigo will show you here a warning sign. So you will be able to take a corrective action. So this is not enough. Basically, we want to understand and find the root cause. So one of the things that the next thing that I will do is I will just click on the function itself. And now what I see is a detailed view for this specific function. I can see all the invocation within the selected time frame. And curious, I can see that the last invocation ended up with timeout. And interesting. So one of the things that I like to use is the graphs. So what we can see here, everything went okay. No, not a lot of errors. Then again, same goes for here. Not a lot of errors. Same here. But for some reason, here we have a jump. So here, every invocation failed, like 4 failed invocation, and also 4 failed invocation out of 4 overall invocation. And if we will look at the time frame, those are those 4. So basically, it means that all the failed invocation here are due to timeout. Now, one of the things that I like to use is this pipe. This pipe basically show me, we call it deployment points, changes, if there were any changes in the function configuration or in the code. So for example, what we can see here is that there were no code changes in this time period. So no one changed anything in the code that may cause the function to time out. But if I will click on the show details, basically I can see that someone changed the timeout configuration from 12 seconds to 5 seconds. Now, when this can happen, all kinds of reasons. For example, we saw that the average duration is a bit more than 5 seconds. And let's say that one of the developers get an assignment to optimize the performance, and he didn't take a closer look, and he reduced the timeout configuration of this specific function to below the average. So this is something that may cause, this may be the root cause. And if I want to test and making sure that, that this is the root cause, all I need to do is I need to click on the go to the AWS console, which will open this view. It will open the AWS console on the function. And what I need to do now is I just need to edit the timeout configuration here. I already did it. I increased it from 5 seconds to 7 seconds. Then when I'm going back to the Lumigo platform, I'm going to change, I did it just before, so I'm just going to change the time frame now. And yeah, that's what I want to show you. So here, this is where we experience timeouts because someone changed the timeout configuration. Now, here what we can see is that when I increased the timeout configuration to 7, which is above the average duration, we stopped getting timeout invocations. So you can see we have invocation, but 0 failures. So Alex, this is one way to basically troubleshoot timeout invocation. But one last thing is I already know that this function, let's say, prone to timeout, and I want to take a closer look to make sure that it does not happen again. So one of the things that I can do is I can go to explore the same page that you showed us before. And here, all I need to do is I need to select timeout. Now, what I can do, and I can also select this specific function, the timeout. And now what I need to do is click at the dashboard. Now, let's call it timeout create unicorn. Let's say that we want it as a chart because I want to follow this function over time. Let's give it a pink color, create. And now what's going to happen is that it was added to our dashboard. So here we have it. We have the widget. The dashboard is customizable, so I can reorder and relocate and locate this widget at the top if this is what I want to monitor. And basically, now I have a full coverage. So we started with alerts, so I can be notified every time any of my production function is timed out. We also identify the root cause for this specific timeout, as we just showed. And to make sure that I also have, let's say, a more proactive approach, I also created a widget, a custom widget that allow me to basically visually monitor and track the behavior of this, or the performance, more accurately, of this specific function. Alex, and I hope that this answers your question, how to troubleshoot timeouts.
Absolutely. Absolutely. And I see that we have a question that's can you do a trace to see what causes the timeout? Yes, absolutely. This is something that we've done a lot, right? So either for like straight up timeouts or for latency issues. And I'll share my screen to show you what it can look like. Right, so in the issues tab, or however, I'm like, okay, I've got timeouts on this function. And then here, by looking at like a specific invocation for it, I can access the timeline view, right? And so, so here I see like all of I have retries on this function. This is why, because it was triggered through Event Bridge. So this function right now, it's not necessarily an amazing example because it does not call any external services. The implementation of the function is kind of cheaty. It is just a wait for 10 seconds. So that's not very interesting. But if I have like if I had calls to external APIs, they would appear in here with the durations, right? The same way that if I look in prod get post deal, here it's going to load, right? If I look at my complete thing, here I can see like, okay, zooming in, like this call lasted that much time, and so on. And so this is like super, super interesting. Like typical scenario would be like, hey, one call lasts for 7 seconds when you expected it to be like 700 milliseconds. So yeah, you can definitely do that.
Amazing, thank you, Alex. One more moment, please. Yeah, so I want to share, Alex. I have an example of what you just tried to show. So yeah, so this is the timeline, and here we basically see an actual function and all the external requests, and I can understand. I have a better view of what happened there. And even one more thing, maybe we can show it, is just this is for me. I want to show you. Okay. So sometimes the timeout is due to a cold start. It happens, right? You didn't take cold start into consideration. And one of the things that you can see here is basically the initialization time, or the init time, the time that it took to the Lambda instance to raise before actually executing your function. So I have a better understanding of how much the cold start affect the invocation, and maybe this is the reason for the timeout. Cool. So, Alex, I think that this is it for today, right?
Yeah, absolutely. Thank you very much, Ron.
Cody.
All right. Ron and Alex, it looks like we did receive one final question. So I will just give one more shout out. If our audience has any more questions, we can probably take about 2 more. So can you do a trace to see what causes the timeout?
Oh, this is the one that we just answered at the end. Yeah.
Perfect. Yeah. All right. Yep. My bad. So we'll take about one more question if anybody can send one in. But in the meantime, I do want to thank our audience for being here. Just a reminder that this session was recorded, and you will be receiving an email with a link to access the recording on demand. You can also find it living on the DevOps website at devops.com/webinars, and it will be staying in the on-demand section where you can find it waiting for you. Additionally, we do have 4 $25 Amazon gift cards to give out, and our winners are Saketh P, Lauren A, Eduardo S, and Kayla H. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. They should make their way over to you in the next 48 hours, but if you don't happen to see an email, check your spam folder just in case it happens to be filtered out. I'd like to thank AWS and Lamigo for sponsoring our program today. And with the couple minutes that we have remaining, Ron and Alex, I wanted to give each of you maybe 30 to 60 seconds to leave our audience with anything you feel they should absolutely take away. So Ron, I'll give you the floor first if you've got anything top of mind.
Yeah, thank you for that, Cody. Yeah, so in 30 seconds. So first of all, what I really I like serverless, and I think that Alex mentioned it before, why sometimes this is the go-to technology for running the application on production. And as a employee at Lamigo, then I just want to re-emphasize on how easy it is to basically troubleshoot a serverless application with Lamigo. Issues always gonna happen. This is the reality. This is software development. And the question is how easy and fast you can respond to an issue and find the root cause so it won't happen again. And I'm really proud to say that Lumigo is a tool that designed specifically for that purpose. And I hope that this webinar helped you to see how easy it is to getting started with Lumigo. All you need to do is connect, sign up, create an Ironwall, use a CloudFormation template, and hit the tracing toggle. And you can stop rely on logs. That's it.
Awesome.
And I'll say on more of the same. Like, we've been doing serverless, not only serverless, but a big take on serverless for a while. And using like the right observability tool has really saved us a lot of time. Today we talked about prod, but that's also valid during development and staging. Even during the development phase, having such like deep insights into what's exactly happening in terms of HTTP requests and everything is invaluable to all of our devs and allows us to save a lot of time. So yeah, if you're doing serverless, I would strongly encourage you to pick a solution. And of course, we're here to help if you have any kind of issue. We've been doing serverless for a while. We're pretty specialized. We have teams in New York, in London, in Paris, in Cape Town, in Casablanca. So yeah, reach out to us. We're super happy to help all of our clients, big, small, and public sector.
Awesome. Well, Ron and Alex, that brings us to the end of the hour. I really appreciate both of you joining us here on Techstrong Learning. So thank you so much for being here.
And thank you, Cody, and thank you, everyone.
Thank you.
Bye, guys.
Awesome.
Bye.
Thanks for being here, everyone. Please stick around for our survey. You'll get funneled straight into it, but we hope to see you at a future Techstrong Learning experience. Have a great rest of your day, and you may now disconnect, everyone. Thanks again.